All right. Good afternoon, sixth period. I hope y'all are having a good day so far. Little change of plans. So I told you guys we were going to do the little paper lab with the sub. But after going through my Wednesday classes today, I figured out that it was going to be way too much explanation, and I just didn't think it was a good idea to, leave you guys to your own devices to figure that out. So we're just going to do that on Tuesday instead whenever we come back. And I'll just have you guys do what you would do on Tuesday today instead. So ideally, if you are here now watching this video, you should have already watched the introductory video to energy flow throughout ecosystems on the current week agenda. It's above this link. But I did want to go ahead and record this video to walk you guys through the notes like I did with everybody today. And then as soon as you're done with these notes, I want you to go ahead and start working on the practice that is in the current week agenda as well, right below this notes link. And then if you finish your work today, I want you to make sure that you've finished your photosynthesis things from this week. So the photosynthesis notes, the photosynthesis lab that we all did together, the photosynthesis product. And then if you are all caught up for me, you don't have anything missing for my class, I've linked a energy flow booklet in our current week agenda. That is what you're allowed to be on. You may read or you may work on other classwork. That is your option for whenever we are done with the notes. All right. So I have it split screen. I would have this slideshow up on the screen, but we gonna make it work. So follow along with me. So we've been talking about photosynthesis and how the energy gets to the systems in the first place through the plants from the sun. So on the screen, you can see a food chain. And I think this is a review from sixth grade. So food chains help to show how the energy in food is passed from one organism to another in an ecosystem. So right here, I want you to type what you see on the screen. You're going to type it next to food chains. Type that definition right here. You can see there are a couple of arrows present in the food chain. These arrows help to show the direction of the energy transfer. So notice we have the grass, our producer. It transfers its energy to the grasshopper. Grasshopper goes to the mouse. Mouse goes to the snake, and then the snake goes to the owl/hawk, predatory bird at the top. So we don't have any arrows pointing at the grass besides the decomposer right here, but that's a different story. We don't have any arrows pointing at the grass because the grass doesn't consume other organisms. It consumes nutrients, but we'll get into that in a little bit when we talk about the decomposers. All right, right below here, there's some room for you to write an example. So I want you to go ahead and write the example that you see on the screen. So right here, you would type grass, and then after the arrow, you can type grasshopper, and then you can type mouse, and then you can type snake, and then you could add owl at the end as well. So if we were in class, I would ask you, what are these guys right here, these little mushrooms? Those are considered decomposers. Decomposers help to break down dead stuff out in nature, and they break it down into simple nutrients that the plants can then reabsorb later on. Also, feel free to pause this video whenever you need to. If you need to copy anything down real quick, if I'm going too fast, you can pause it. All right, moving on. So starting at the very bottom or the first level of the food chain, we've got our producers. So right here, I want you to type the definition that you see on the screen. A producer is a plant that creates its own food. It gets its energy directly from the sun. So it absorbs that radiant energy and transfers it into chemical energy through that process called photosynthesis. Now, these producers store a ton of energy. And when we go into the energy pyramid in just a minute, we'll talk about how the energy is lost over time, but right now, just focus on producers being plants that produce their own food. For the example, you can write whatever your favorite plant is. Maybe you write some kind of flower. Happy Valentine's Day, by the way. I would tell you if I saw you. So yeah. And then just know that the producer is always going to be the first link in the food chain. All right, a couple of definitions here that I'm sure you're familiar with. So we'll start with primary consumers. Anything after a producer is a consumer. So consumers must eat other organisms in order to get their energy. They can't make their own food. So we've got primary consumers, the first one. if you're talking about something being your primary goal, right? It's your number one goal in life. So primary consumers are one arrow away from the producer. So when we're looking at a food chain or a food web, the primary consumer is always one arrow away from the producer. These guys are always herbivores. They're plant eaters, and they're the first organism to eat in the food chain. You could list out grasshopper. Cows are primary consumers because they only consume grass and plants. And then deer are primary consumers as well. Think of whatever example makes you happy. As long as it's an herbivore, it's something that eats only plants. And then the secondary consumers, they are the second eaters in the food chain. So if we're looking at a food chain, we find the producer, we go 1, 2 arrows away, and that is our secondary consumer. Obviously, if you're in second place, you are number 2. These guys can either be carnivores or omnivores. It really depends on the food chain that you're looking at. And then in this case, we have an example, the mouse right here. So you can write that for your example too. And then tertiary consumers, those are the third consumer in a system. So they are 3 arrows away from the producer. Again, we find the producer, here's the grass, we go 1, 2, 3 arrows away. In this case, the tertiary consumer would be the snake. These guys they can be omnivores, they can be most often carnivores, I would say. But again, I'll show y'all later where organisms can be tertiary consumers or secondary consumers. It just really depends on the specific food chain that you're looking at. And then finally, the apex predator. That's the top guy in the food chain, number 1, head honcho, like a killer whale or a tiger or a lion. They have no natural predators. A lot of people assume that humans are apex predators, and although I kind of agree, I do think that if you stuck me personally out into the Denali National Park in Alaska without any tools, I don't think it would end well. So I don't really consider humans apex predators because we kind of hijack the system with all of our tools, but whatever. Anyways, you could write whatever example you want. Hawks, tigers, lions, killer whales in the ocean, anything like that. All right, on to decomposers. So super, super important because they help to recycle all of the nutrients back into the system. So decomposers get their energy from dead or decaying organisms, and they break that nutrients, that dead stuff down, turn it into nutrients, and put it right back into the soil for the producers, the plants, to reabsorb. So plants have to have nutrients in order to survive. Yes, they need sunlight, of course, and they need water as well, but they have to also absorb things like nitrogen and phosphorus from the soil in order to grow. You'll notice if you have any houseplants in your home that, the soil that you buy from the store has lots of nutrients in it, but over time, if you don't add more fertilizer to your plants, they start to get unhealthy and sometimes get yellow leaves around the ends or brown leaves because they don't have enough nutrients to survive. Okay, some examples are mushrooms and some bacteria. So those guys, you'll find them a lot on like dead logs in the forest. I'm sure you guys have seen some mushrooms in person. Find them a lot of times after it's raining as well, or after it has rained. Okay, on to herbivores, carnivores, and omnivores. That should definitely be a review. So herbivores, when you're thinking of herbs, right? Think about cilantro, parsley, thyme, oregano, all the yummy things that help make our food taste good. Those are all plants. So we can think of herbivores being only plant eaters, like grasshoppers, cows, zebras, wildlife that relies only on plants. Carnivores, the first part of this word, carne. If you're in Spanish class right now, you know that carne means meat in Spanish. So carnivores eat only animals. They eat only meat. They got nice sharp teeth. That's an adaptation that helps them tear through the meat. So you could think of lions, tigers, any meat eaters only. And then omnivores. These guys eat both plants and animals. So humans are omnivores, although some humans might be herbivores by choice. We're still biologically considered omnivores because we're capable of digesting and consuming both of those things. All right. We're now onto the second part of the notes where we'll start to talk about energy pyramids and what those are, but just kidding. So I would have asked you this question. Pretend you can't see the word no here. It says, do you think herbivores get as much energy from the plants as the plant gets from the sun? The answer is no. So I think this is a review from last year. As we move through the food chain to the top, the amount of energy decreases in availability. So what organisms get from the things that they consume, the amount of energy that they get is less than what the plants originally get from the sun. All right, here's an energy pyramid. So each of the different rows in here are considered different trophic levels. So think about the word autotroph, heterotroph. They're the levels of different types of eaters or producers, right? So at the very bottom, we have our producers. Then we have our primary consumers, secondary consumers, tertiary consumers, and then we have a couple extra here. This is a very detailed energy pyramid. But anyways, what does it show? It shows how much energy is available to organisms at the next level of the food chain. So it shows, what percentage is capable of being passed up and up and up. And of course, there's only a few guys at the top. And what I would say to you in person is when we're thinking about walking around outside, I would ask you the question, do you see more producers out there? Do you see more plants? Or do you see more apex predators? And hopefully you would say that there are a whole lot more plants than there are apex predators. And the reason why is because it takes a whole lot of energy at the bottom to support just a few organisms at the top. So much of that energy is lost in organisms that never get eaten, or in waste or heat that's generated. So a lot of that energy is lost through the system and can only really support just a couple at the top. Okay, let's fill out our pyramid together. So I'll type on the document on the right side so that you can kind of see what I want you to have. So if you double click in here, it'll bring up Google Drawing like this, and then I have the text boxes already for you in the Google Drawing, so we'll type together. At the very bottom, we have our plants, so let's type producers, and then we can put in parentheses plants. Okay. One step above the producer would be our primary consumers. And then one step above that, we would have our secondary consumers. I'm just going to write secondary. And then at the very top, we have our tertiary. It's kind of small. Get a little bit bigger. All right. So this is our energy pyramid. We got the different levels. Now, here's the new thing. I don't know if you all have learned this yet or not. At each level, only 10% of the energy stored at each level gets passed up to the level right above it. So if we have 100% of the energy, right, they get all of that energy from the sun. 90% of that energy gets lost to either organisms that don't ever get eaten and they just die of natural causes, and that energy never gets passed to the consumer above it. Or in waste or in heat. So we have 10% at the primary level, 1% at the secondary level, and then 0.1% at the tertiary level. So we can put some numbers to this and make it a little bit easier to understand. Now, I'm never going to ask y'all to do any complicated math. Literally, all this is memorization. So as you can see in the numbers, we could start with 1,000 calories worth of energy stored in the producer level. All this is saying is if we added up all the grass together, they're worth this amount of energy. If I took 10% of 1,000, all I have to do, you guys, is delete a zero from the back. So delete a zero on the end, and we have 100 calories worth of grasshopper able to be supported by this amount of grass. Okay, 10% calories of mouse. I know that sounds weird to say, but I don't know really how else to say it. 10% of energy stored at the mouse level, whatever. Anyways, and then if we take off 1 0 from that, then we would have 1 calories of energy at the top level. So in other words, in order to support just 1 calorie of energy up here, we have to have a whole 1,000 calories of grass at the bottom. Otherwise, it would not be able to sustain this ecosystem here. And when we do our simulation next week, when I have you guys, we'll do it together. You guys are going to see this in real time. We'll be able to delete half of the grass away, and you'll be able to see how the other organisms get affected whenever we, remove a chunk of one of these populations. Okay, let's add a couple of things to our little pyramid over here. So click on the text box, and then you can highlight over here. We're just going to add the numbers to help us. So if we're told that we have 1,000 calories of producers, then if we were deleting our 0, you know that we would have 100 calories. We're just going to copy down those numbers. That way you have that available. Copy and paste that. Yeah. All right, so I'm going to do just like a side example off to the side with y'all that I would have done in class, but obviously kind of hard to do over video. So what if and this is kind of how your test questions might be set up later on. What I might do is I may give you a value. Let's say I said there were 2,000 calories stored at the primary consumer level. You can easily figure out the rest of this information by just adding or subtracting a 0. So if we're moving our way down, we're going to add a 0. So right below, at the producer level, in order to support 2,000 calories of primary consumer, we would need 20,000 calories of producer. And then in order to support, or just going on the opposite spectrum of that, if we're talking about 10% of the energy going to the level above it, we would have 200 calories at the secondary level. And then finally, we would have 20 calories at the tertiary level. So all you got to do is memorize that when you are moving your way up, you just have to delete a 0 from the end. And when you are moving your way down, you just add a 0 to the end. Pretty simple and pretty easy math. All this is showing is that as we move our way up, there's less energy available at the top. All right. Then we can hit save and close. We're done with that. So, what is a food web? What is a food web? First, let's answer this question real quick. It says, who receives the least amount of energy? Hopefully, you can say that the tertiary consumers would receive the least amount as it decreases when they go up. All right, where is my food web? There we go. All right, so food web. It is a much more complex way of representing what is present in an ecosystem. So think about it like many overlapping food chains. We could look at the food chain between the grass, the grasshopper, and the snake. We could look from the grass to the grasshopper to the weasel. We could look from the grass to the mouse. Lots of different overlapping food chains. It's a lot more realistic as, many organisms are consumed by other organisms and many organisms consume the same organisms. Again, it depends on the food chain that we're looking at. So copy down that definition. Right here in the example food web, you could screenshot this and include that in your notes, or you can go and Google search and find your own food web. Now, here's a question. If I were in person with y'all, I would ask you, how is it possible that the snake is a tertiary and a secondary consumer? So it depends on the food chain that we're looking at. So if we look at grass to grasshopper to snake, that is 2 arrows, making snake a secondary consumer in that specific food chain. But snake could also technically be a tertiary if we go to grass to grasshopper to possum to snake. Right there, we had 1, 2, 3 arrows in between. 3 and tertiary both start with a T. So that can help you remember that with tertiary, there are 3 arrows in between. Okay. Now, the other thing that I want to make sure I emphasize to y'all is that I don't want you to just look at the top and assume that the organisms at the top of the food web are the tertiary consumers, because that's not always the case. Okay. It really depends on the amount of arrows that you have present. So if you're looking at this, you might say, oh, weasel, he's tertiary. But if we count the arrows present, we can go from grass to grasshopper to weasel. That's 2. Grass to quail to weasel, that's 2. Weasel is not a tertiary consumer. Weasel is a secondary consumer. Now, if there was some kind of third arrow in here, then sure, we could call weasel a tertiary consumer in that specific food chain. But in this case, although weasel is at the top, weasel is not a tertiary. He is only a secondary consumer. All right. That concludes the notes that we have for y'all. If you have any questions at all, please email me. You can shoot me a quick email. I may or may not answer it this weekend, but we'll try to check that a couple of times just to see where you guys are at. I hope everything is going well. Hopefully this makes sense to you guys. Go ahead and go to this link on Canvas. Make sure you go turn in these notes. Go ahead and do that now that we've done them together. And then go ahead and start on the practice. I'll walk you through where that is while I have you. There should be your practice linked in Canvas. It's going to be one of those Google assignments where you're able to press the blue submit button whenever you're done with it. If you scroll down, we're on Thursday. Thursday looks a little bit different than Wednesday because you guys don't have me in person, obviously. Click on the energy flow practice right here, and then you should be able to complete that independently. When we come back to school on Tuesday, we can go over the answers together and just make sure that we're all good with that. And then once you finish that and turn it in, I want you to finish your photosynthesis playlist from this week. So that, again, is the photosynthesis notes for Monday, the lab that we did together, the product, and then make sure you finished anything else from my class. And if you are, you can click here and further your knowledge in the flow of energy throughout ecosystems. Miss y'all tons. Hope everything is going well. And I hope y'all have a fabulous 4-day weekend. And I'm looking forward to a little 4-day week with you guys. All right. Thank you so much. Have a great rest of your day.